Hello, Stefan.
Hi, how are you?
I'm good. Welcome. We're going to talk about what you guys are doing at the Lostboyslab. You have some pretty amazing things going on, and you've been a client to us for one and a half years now, I think. So just to give everyone out there sort of a small insight in your business and your visions for the future. So how did everything started here in Sweden with Lostboyslab?
Yeah, so I mean, in a way, I spent 32 years of my life in the CAD industry, 3D, everything from virtual reality to gaming, and main part in the BIM area in kind of digitizing the AEC industry, but always also including mechanical CAD and these kind of things. So yeah, it was time for me to make a new startup, and when you had a pretty long career and a lot of entrepreneurial adventures behind you, you are in a good situation where you kind of can choose what you want to do. And obviously, I'm extremely interested about what will happen now in this 3D printing revolution, and where everything we're going to talk about today, Patrik, obviously. So we started in stealth mode, basically, for almost 1.5 years ago, when actually we first had our initial talks. And the whole concept of Lostboyslab is that I always joke that this is my answer to an MIT Fab Lab, but I want to democratize it. So we give more people an opportunity to come up with innovations and these kind of things, and we will help them and guide them all the way from prototyping to manufacturing and so on. And Lostboyslab is like a network of more companies, but itself it's like a think tank or a think tank. So a lot of tinkering, a lot of thinking, and there's a lot of mistakes done here at the lab, and sometimes things set on fire and we destroy things and so on, but that's the whole intention, and that's also the connection to Peter Pan and Neverland. And we try to do magic in our own way, and we try to still be curious and really don't be too guided by things that have already been done. Instead, try it out ourselves. So I think that's the way to describe it. Right now, we are in the Alpha Zero lab, a part of it. We are not actually in the 3D printing farm because it's way too noisy. We cannot sit there. So we are in a different part where normally it's also noisy, because here is like carbon fiber ovens and vacuum systems and shredders and stuff. But right now it's silent, so we can have this call.
Yeah, well, I mean, I've seen a lot of. I wouldn't say similar, because there's. To be honest, I haven't seen anything similar to what you are starting today so far in my years in the additive industry. But I've seen a lot of people trying and starting up things. But what's really amazed me is the fact that, I mean, you reached out to me and we started to have a really good connection, and of course you bought some machines from us, but then things devolved really quickly. So it really seems that you get things going in a way that is pretty uncommon, I would say, for similar business startups here in the Scandinavian area.
I think it's the entrepreneurial thing, that speed is of essence. So, and also being a race car driver, it's all about speed, so you need to act fast, and you need to try things. You need to dare to try things, and sometimes you crash, and it happens the same here with 3D prints. It's better when you crash with a print than with a car, but
yeah. And I mean, I've seen, of course, you're really active on LinkedIn and stuff with a lot of things around recycling waste out in the world and things like that. So, what's your view on that? Because I mean, we do add like plastic materials to the world in one sense.
Yeah, no. I mean, I call myself a plastic pollution fighter. So obviously, I want to solve the plastic pollution problem in my way, in an engineering way, and obviously reuse the resources we have already created in form of plastic, and doing that both in the micro scale, so it can be done in the garage in a very small 3D print factory, but also trying to solve it with larger waste streams, and also trying to build a solution where we can build a circular way of thinking, so we can collect the PET bottles on the beaches of Kuta Beach in Bali and get the kids to start to figure out that, hey, this is material for my 3D printer. This is not waste, and we need to clean up the beaches, because now we can go to this Lostboyslab or this 3D print place, and I can actually make toys for my little brother, or I can make a spare part for my bike, or I can do something for my daddy's moped or something, or to mommy, I can do new things. So that's of course my vision, to reuse stuff and make it circular, and we do it a lot of times. Of course, there is always issues with safety. So if it's a part that we'll talk more about later, like it needs to go into a car like this, or there is a static electricity or a risk of fire, or sometimes we cannot use the recycled material. So we will use it as much as we can, to be honest, and try to find circular ways. For sure.
But I know that we discussed some some ideas around like shredding used waste plastic material and actually do like molding of maybe household parts like plates or
Yeah.
things like that, which I think is it's a really, a lot of times you sort of think about really expensive injection molding machines, and that will probably put some demands on the quality of the plastic that you put in. But if you keep it on like a low tech level, you can actually like do pretty cool new stuff with pretty rough waste. But what kind of waste are you looking at, like recycling? Is it everything from
it's all over here. I don't know, do you want me to turn the camera?
yeah,
I can
sure.
show you a little bit. So this is actually a one collection unit. So this is actually everything from PET, PLA, LDP, PP. So everything goes in, and that's typically, I mean, COVID-19 has been bad for the plastic waste, because now we don't go to the restaurants and eat on porcelain anymore. Now we order home and we get plastic every time, and every box you have is black PP, and some of these plastics we probably will not succeed in doing into filament rolls, and but then we're going to use. Do you want me to, should I show what I'm? So
Yes, of course.
This is actually done on the Onyx one. So these are molds. So we have big hopes. So it's simple injection molding. It's not a huge machine molding, but we have big hopes, and working also with ways where we look at water cooling these, since we are very much into the motorsport arena and we know about engines and stuff. We have some ideas, and we think this will be brilliant, because we can then create molds for very okay. This takes a lot of onyx, but still, just imagine what a real injection mold, CNC aluminum mold would cost.
And maybe the problem too, especially if you're in a remote location like an island or something, where actually sadly a lot of the waste are ending up on beaches and stuff. I mean, it's pretty difficult to mill a tool like that, but placing, for example, Onyx One on site and print the molds on location is
these are Onyx
doable.
only. These are not even reinforced, and
yeah
I mean, this is also what we like with Onyx. They are so accurate in the dimensions. They are so precise, and
Mm.
so we have big hopes that this will work. We are right now constructing one mold machine in Spain, so we're expecting it in a month or so. But we already had some initial tests in other places where we see that it most likely will work. We will see in the factory how much wear and tear it will be, and how many molds it will last until it actually loses its detail. But we have big hopes that it will work really fine. And that's typically one of the things, you know, we just try, we do mistakes, we try different ways, we do workarounds. And that's also what I love with 3D printing and 3D modeling, because with this technology, there's not much of constraints. You know, we can build these water canals like completely organic if we would like to, you know, because it doesn't matter for the 3D printer.
Yeah.
And so that's really exciting stuff.
Cool. I also see, I mean, I'm a race car freak myself. I've been doing some go-karting and stuff in the past. I see your Porsche there on the side. Yeah, I know, exactly. Super sweet. But I mean, on your homepage, which we can, you know, put a link later on to your homepage, but you're presenting your Porsche project. Could you tell us something about that?
Yeah, so the Porsche project is like, we need something to test everything on, and that's of course a little bit the problem with doing, you know, these kind of engineering design and so on, that a lot of projects are secret. So some of the best projects we are involved in, we cannot talk about. So that's why we also decided we're going to do our own car. And this is actually a Porsche 964, actually 911, but with an internal number of 964 from 1991. So it's more than 30 years old. It's actually already in carbon fiber. So it's turned into, I will show a little bit, it's turned into an RSR. So if you get a look on it, so because RSR was a very, very special version of the 964, it was their race version. They only built, I think, 62 of them, and almost none of them were built for the road. It was a track weapon, or actually a competition weapon. So what we are doing now, we are taking the whole car apart. So the chassis is already all carbon. You might see it up here. It's all carbon, not made in a 3D printer. So it's all carbon.
Yet.
Yet, yeah, that's right. So what we're doing now is basically electrifying it. So it will be an EV RSR. I think it will be the first one in the world. Nobody made an EV RSR. There's in California, where I lived a couple of years, they do a lot of EV conversions, taking crashed Teslas and modifying Porsche 911s. But we are right now in the project of removing the engine and removing all things that is connected to the combustion engine. And then this will be a lot of 3D prints in this car. So this car will be traditional carbon fiber weaving. There will be a lot of Onyx printed MarkForged parts in the car, and we will electrify it. So should I show some things, what we're doing, Patrik?
Yeah, please, go ahead.
I mean, this is actually one of the potential battery packs we will use. This is now printed on Prusa with PLA. So actually simple, just to get, obviously we 3D scan everything with the Einscan system, what we bought from Trader Verkstan.
Yeah.
So we do 3D scan, and we do all the testing in Fusion 360, but we still want to feel the physics, you know. So we also build these prototypes and start to really look, how can we place the batteries and where we can place the batteries. They need also water cooling, you know, so you can use different outputs and inputs. So we will basically simulate everything before we order the batteries, and that's pretty amazing. You can do a full test and see. And it will not be enough to staff up the front here with batteries. We will need to have batteries. We will make the car into, we will remove the small child seat in the back, you know. The 911 of this time have very small seats in the back. Those will have to go. So we will pack batteries back there too. And obviously the engine will be in the back where the 911 engine is also.
Yeah.
So that's with the batteries. Other than that, we are doing a lot of different. So this is for the connection. So some parts we don't do, like tubes. We actually buy them from Easy Composites in the UK, but this is directly printed and scanned. We also work with a lot of other enthusiasts that are keeping their engines, and this is a famous guy from Island Works in Gothenburg. So he is actually building the probably the lightest 964 in the world. So complete strip, and yeah, we 3D scanned his car. He's working in SolidWorks, creating parts, and then we're printing them, and these babies go straight into the engine.
Yeah.
This is not a prototype. This is the real deal.
I think that was like one of the first parts you printed on your first MarkForged machines.
Yeah, this was the real test, because this was very, very hard to print.
Yeah.
And it was like 35 hours of printing time. So
yeah.
But we tried different ways of printing it, and we learned a lot. And to be honest, when I printed this part, and I saw Jonas' reaction in Gothenburg, and we saw the stability, and I really, this was a little bit one of the small deja vus. I know deja vu, like aha, like wow, this will work, you know. 3D printing is now at the point where we can make parts.
Yeah.
You know? We can make real parts. So other things we're obviously doing for the car, it's hard to go around it now, but we're testing new ways to do a carbon fiber. So and there's so many ways to do carbon fiber parts, but when you work with a vintage car like this, and we have like a lot of surfaces which doesn't really exist in normal production cars, because you actually never see a 964 RSR out on the streets, and there's no spare parts to find from Porsche. Forget it. So everything had to be made. So this is a canard. It actually goes here on the side of the car. So it's like doing two things. It's increasing the downforce on the front, and it also creates a swirl for getting more air into the brakes. So this is actually 3D printed, and it's really in draft mode, very, very quickly printed. And then next step is we wet lay carbon fiber on it. And of course, this is now handmade, but it's made from the 3D part. So it's very, very quick. And then you get into the next phase where you have to do polishing, and you remove things, you make it much more softer. And this is almost the final ready part, but it's one layer of carbon on top of the print.
Yeah, and so you're using the 3D print as a core, pretty much.
Exactly, but you know the speed of which we can make these, and we can make each one individual. And this even have, and that was it's a lot of mistakes still on this one, but here is an NFC chip inside. So this is even coded, so we can actually blip this with our Whatio technology and keep track of the actual component. And even in competition, that's good, because then you know that it's an original part.
Yeah, of course.
Fiddle around with it. So, but this is the whole carbon fiber experience is far from ready or anything. You know, we are in the midst of it. So, I mean, looking at these parts, this is the next step we are working on now, which I cannot show because we also want to do molds for laying carbon fiber weave.
Yeah.
And I know that that's something that will be really huge, because the carbon fiber process today is too manual, you know, and it's broken. There's too many human steps in the process. But I know with what we are doing together, I know that this we can do very, very quickly. And then just produce parts from the mold, but everything comes from the 3D printer. So you scan, you design in the context of the car, you make a mold or a part or an injection mold, and then you can start producing or a core. So this is many different ways, you know, but yeah.
You mentioned this Whatio. It's also available on your homepage if everyone wants to read more. But can you give a short description around that? Because I think that's really something we are facing almost every time when we discuss with clients, often the larger clients like big industrial companies, they have, you know, especially during COVID years now, 2020, the supply chain management is like a pain in the ass for a lot of companies. And the fact that what you are thinking about here with Whatio is really a good step in the correct direction.
Yeah.
Could you give a short info about that?
Yeah. So I mean, Whatio is basically a digital spare parts catalog, but we want to solve. There's so many things to solve in that area. Of course, who owns the right to the model? Who has the IP rights? Who should get paid for making the model? And right now, if you look at the platforms available today, they're all like hobby platforms. Anybody can upload anything, and everything is STL basically, you know. And you just hate to bring down an STL file. You cannot do anything with it basically. You have to remodel it, redraw it, and so on. So our vision is to build something professional, where real companies like anything from Electrolux, Husqvarna, Roca Group, Porsche, Lamborghini, they can actually build their own intranets, or they can decide themselves how it should be protected or not protected. And they can also decide, do I want to download something for people to adjust? So you could actually let people get a step file, or even better, get a pure SolidWorks or a Fusion 360 file, and let people modify it. Because if you think about spare parts for this old car, there's thousands of enthusiasts right now building stuff to the car, but nowhere is it collected, you know? So, and obviously other things which we want to get into, and we are deep into, that is to connect the Whatio platform, to connect the physical product with the internet. So I call Whatio in a way a passive Internet of Things platform. So this is not printed on a MarkForged. This is actually recycled natural PLA. But here is the NFC chip, if it's visible. So I can just show what we can do on this. And we solved this in a brilliant way, because there's no app on my phone. I'm just running the app. And if I do that, it actually opens the browser. And now I have all the different information about the product, where it's manufactured, who is owning it even, assembly instructions, of course, no paper. You can have all the assembly, disassembly, material information. It was recycled PETG, I was wrong. And then you can get the material data sheets. They are here in PDF. If you want to have spare parts to it, you can then go into the spare parts section of Whatio. And then obviously you will know, can I print some spare parts myself? Or can I order them? Or can I go to farm and farm them out? And then there is the most important thing, is the recycling information. So if you need to recycle this, you can know exactly where you can go and get it recycled. So that's like a very important part of Whatio. So it's a little bit like a material passport, and an ability to allow designers and engineers and IP owners to distribute content in a safe way, and then go to the printer. Because, you know, Patrik, you're also a modeler, and you know that there will be 0.01% of the world's population that will know how to run, you know, CATIA or Fusion. There will be many millions, but we're billions on the planet. So we believe that having good and available models for searching, filtering, finding, and maybe even image recognition of what, you know, vacuum cleaner you have, you should have the ability in many cases to print it at home in your garage, or go to a farm, or order the prints, you know, locally, and maybe even from recycled material, maybe from Onyx if it's for a car. So this platform we are developing in Gothenburg, together with some other companies. Right now you can only see some alpha early stage things online, but I think in a 3 to 6 month period we will push out a little bit more of examples what we can do. I can give you another example with vintage cars, which is really annoying. It's a good example too. These are centering rings for putting rims on the car. And the rims to this car was bought in Germany original Porsche rims, 25-year-old. And the problem is they are a little bit different, all of them. And the axle is pretty worn out. So you need to have these centering rings to get it to be firm on the axle. And the stupid thing is that there's so many variations, because you have to have inner and outer diameter on the 0.1 millimeter tolerance. So for anybody, you will need thousands of variations. And these are injection molded in China. Just imagine, they injection mold these. They send all these different variations to 10,000, 100,000 dealers all over the world. And then when you and I get to that shop, we need to find exactly the one that fits our purpose, which we won't probably fit. What we do instead, we just use the parametric nature of modeling. And this is so simple to model. It takes like 1 minute to model in Fusion to make a parametric model. You take 2 dimensions and then you manufacture these in less than 45 minutes on one printer. If you have 4 printers, which you like, that we have for many printers, you print them in like 16 minutes or something. Yeah. So this is like feasible, even if you think in the longer perspective, even like a tire shop, you know, they would be able to have an Onyx One if they would have the tools, if the digital platform would support all their daily issues and problems, and if they are customizable, because that's the name of the game with 3D printing, to make it mass customization, not mass production, because this we have to stop. It's all Chinese, you know, and just imagine the carbon footprint on these plastic things.
Yeah. Shipping them, and then you buy 10 of them, and you will probably use one of them because the other one is the wrong size, so you have to scrap the rest. And I mean, I think it's funny because when you scan this lamp and you see, you know, you can see like there's spare parts for this particular products available to download and print, for example. I mean, I'm just thinking about my own home, that I was actually in like an interview with a Swedish like forum called Bygga Hus. So they're not into 3D printing at all, but they were like, this is something that we see are discussed on our home forum a lot. And so what is this? So I just went around in my own apartment and took pictures of everything I printed. And I just realized that, I mean, I haven't bought a spare part in 3 or 4 or 5 years, because it's quicker for me to just take the broken part, if it's a handle to an old fridge or whatever, glue it together, scan it, design it, print it. Or if I need some kind of, you know, custom fittings for putting up a bit thicker what do you say, like bar for the shower curtain. I can just design it in 5 minutes and print it, and in 1.5 hours I have my product and I can put it up on the wall. So I just have loads of those things. So if I can, when my fridge handle is broken, if I can just do an NFC reading on that and see that, oh, hey, there's 3 parts you can print for this. It doesn't have to be the whole fridge, but at least a few ones, then that's something I would use directly. And I think the world needs that kind of, you know, localized production in one way, for sure.
And the beauty now with NFC chip, since Apple and you know, Google and Samsung, they're all focusing, and the credit card companies are using NFC. Suddenly every new mobile phone becomes an NFC reader. Yeah. That was the problem before with RFID, because RFID is too expensive, you know, and honestly, we buy these on Amazon, the Chinese manufacturer. I think we pay like 15 cents in the US dollar, 150 Swedish. It's nothing.
Yeah. And the value it brings to a product is a lot more, of course, than that. But I would like to talk some more about MarkForged and how you, because I mean, now I know that you guys are running through shitloads of different 3D printers and brands, and you have a big mix, since you do everything from you know, parts that needs to be in a car actually holding up to you know, printers that needs to be able to print a recycled material, which can be a bit, you know, up and down when it comes to which temperatures that's needed and stuff. So you have both open systems and you have the MarkForged system, for example. But if you think about your journey when you added your first machine and then added more, like how have your experience been with MarkForged as a 3D printer?
I mean, it's been out of every single brand, and I don't know how many brands tested right now, 12, 13, 14 different brands. So, I mean, also we have been focused on the FDM printers, because Yeah, there's a lot of things I don't like with the powder and all these kind of things, but that's a subject for another call. So it's mainly FDM, and MarkForged have been by far the cleanest, simplest, smoothest we have had. Obviously, we only print in onyx, which makes things easier because it's always the same material. So we cannot print in other materials, but it's been really slick. So I mean, I feel like you get what you pay for, you know, and you feel also that it's the software, the beauty of having everything integrated when you use like Cura or, you know, Prusa Slicer, you have 150 different options to, you can set everything, but you can also make a mistake with everything. So it takes much longer to get consistency and work on the cheaper printers. With a MarkForged, it's more or less you cannot do much because you can tell do you want support or not. That's basically, you know. But on the other hand, it just works. So I really feel they are what I call industrial printers, even the desktop ones, like the one we have here. They just go and go, you know. It's almost, if you just know how to model right, because that I can tell that was probably the biggest thing, you know, with a lot of stuff we get in from, you know, customers and these kind of things. There's so many ways they model, and that is the biggest problem with you know. So
like the knowledge of you know how to design for additive.
exactly,
yeah,
exactly.
yeah,
And so almost everything we get, we remodel if we can. Yeah. So that was, I think, with MarkForged, that was the biggest learning curve, really, to learn the materials, characteristics, the machine. At first, I was skeptic, and you remember our calls. I said it's so small, you know. I need a big printer. I need to print big things, you know. But then you're starting to realize that there is so many engineering ways to sort it out anyway. And you know, I was really happy when you sent me these. Remember when we talked about?
Yeah.
And this is also what we do. We do a lot of these test benches, and I think you had this idea and told me just make all these things, and we do the same.
Yeah, I mean,
roll bearings and things, and that's another thing with Onyx and MarkForged. If you know, if you do the same in PLA, you will see that it varies a lot, even from print to print. You also see that you don't have the same tolerance. With Onyx, it's almost exactly, it's actually almost always 0.0 where the roll bearing fits with a good tolerance.
Yeah.
But we have about 0.2 always with PET or PLA, depending also on the different printers. So no, it was easy. I mean, really, really, really easy. I mean, the software is so intuitive, and it's by far the best software out there, by far.
Are you, so you're always printing on in your, because you're localized in one spot now? I haven't visited yet.
No, that's,
I mean, I probably should have if this.
So Patrik, is it because of COVID or because we are from the south?
Yeah, no, it's pure COVID, I promise. Otherwise, I would be in your Porsche. Yeah, for sure. No, but you have everything localized now in one spot, right? Or are you spreading out machines?
No, we have more or less everything which is FDM. We have now in the lab. So I think it's like 42 printers. I think we have 6 machines from MarkForged. So 1 Mark II and the rest is Onyx ones. So we are expanding with other monster printers, which is like totally different scope. It's more like, you know, making furniture with 3D printing stuff. So I call them monster printers because they are like 1200 by 1200 by 1500 build plates. So it's another game.
Yeah.
These are 8mm, Patrik. They are not.
Yeah.
So it's totally different. They are not here, obviously. So in this lab.
But you said something before around your expansion plans as well. Are you looking at doing this, you know, because now you're pretty local in the southern part of Sweden. Yeah. But what's your plan if we look ahead now? I mean, it would be interesting to hear. I mean, what's your what's your dream when it comes to MarkForged? I mean, there's of course always things that you can wish for. What would that be, and what's your plans with Lostboyslab going forward?
So I mean, there's a lot of tentacles out from this. So from a location point of view, Gothenburg is the next step, because in Gothenburg we will do all the Whatio developments, and you cannot build Whatio without having a farm, because it's all about farming, and we will of course be the main kind of think tank down here, but also Gothenburg will be important for us with the software things. We are doing a project which I checked. I'm allowed to say it's for United Nations, so we cannot use the logo, but we can say, and it's connected to a Swedish innovation and environmental incubator, and there we are building microfactories in 20-foot shipping containers. So these will be built in Ljungbyhed at the old military airfield, and this is actually where we also have our motorsport activities. So it's kind of, and it's good. We will be in a old hangar, and the hangars are great for containers, because then we can build everything inside in a dry space. So that's the basis of that, and that means that we will have small Lostboyslab in the form of, we call it the MMU, a mobile maker unit. I think we are looking at Cameroon and Antigua as the two first tests. Mm-hmm. We also have some ideas to show our technology with the Swedish Touring Car Championship this year. We really hope that COVID will be over, so we will have the spectators back, because last year was racing without any spectators, which was really weird. But then my expansion plan is Los Angeles, for sure, California. We work very closely with Stanford University in Silicon Valley, and we want to engage more into research and these kind of things. And LA is also a good place, or California, to start up this business. So that's one of our goals. There will be a third Lostboyslab somewhere down end of 2022. Probably in Asia somewhere. We have not decided, but the plan is to spread out, but not too many of the research labs, because they're expensive. So we have to find separate business ideas and concepts where we typically help entrepreneurs. We find a way, and then we also invest as business angels, and we have a big network. We can actually engage into some concept and help them with all the spare parts and the whole design, and even manufacturing things from scratch. So
exciting times.
Yeah,
sure. Yeah, cool. I think we've been out for 40 minutes at this point. So I have to say thank you for joining the call. It's really interesting to hear what you guys are working on, and I hope everyone can go to your homepage and read more, and also follow you guys on LinkedIn, where I know that you're really active on posting stuff to get more info.
To share, Patrik. I think it's more fun for makers to share things. I mean, a lot of people do patents and they hide what they're doing. We keep it open, because if the things we do, we can do it really good. People will come to us anyways, with or without a patent. It won't make any difference,
No, of course.
So, and know what I like with FDM too?
Tell me.
You can put super magnets inside the prints.
Yeah.
No, but actually that's a big thing. So this one comes out of the Onyx as a finished product. So it's a clip for a scarf hanger. So it's laser cut leather, and then super magnets in both ends.
Okay.
And you just put a two poses, one for the leather band, one for magnet, and the product is done.
Yeah. So that's actually like a clothing products that you are producing and selling as well.
We have one customer, so she is using a lot of super magnets and stuff in her designs. So this for holding a towel, or you can hold up a scarf on the wall and these kind of things, and the magnets hold it together. That's also what I like with having these machines, because you can make more ideas with them. If you have a closed system with powder, you can't stick your hands in there during printing, right? I mean, it's kind of impossible.
Yeah.
So no chips, no integrated things at all. You are stuck.
Cool. All right, I'll let you go for today. I hope the weather is better down there than here in Stockholm, because
the sun is shining today.
Yeah, we got a shitload of snow yesterday again, so the winter's back. But nice talking to you, Stefan, and let's catch up later.
Yeah, have a good one.
Thanks for today.
Yes.
Bye bye.